In this lesson, we are going to talk about what is the difference between conventional current and electron current. So these are lecture objectives. In our previous lesson, we were taught that electricity moved through a complete circuit is the flow of electrons. That is why most electrical conductor materials contain some way of allowing electrons to move within their material. For example, all metals conduct electricity as there are free electrons in the metal. So if you know about structure of metal, so you know that there are free electrons within the metal and essentially they are able to move about. So the outer electrons are so weakly bound to the metal atoms that they are free to roam about the entire metal. So electrical insulator does not allow electrons to move within it, thus they cannot conduct electricity. Some examples are rubber and plastic. However, this does not mean that all non-metals are electrical insulators. There are some non-metals that can be good electrical conductors as long as it allows electrons to move within it. So the key thing is allowing electrons to move. One good example to illustrate this idea is carbon. Carbon atoms can group themselves in different ways. The picture shows two different ways which present itself into two different forms, diamond and graphite. In diamond, each carbon atom forms covalent bond with four other carbon atoms and there are no free electrons. 1, 2, 3, 4, and so on. Okay, and in graphites, each carbon atoms only form covalent bonds with three other atoms and thus there's a free electron. The result is that though both are essentially carbon, diamond cannot conduct electricity but graphite can because there are free electrons. Electron flow and conventional flow. If you look at most electrical circuit diagram, you would have noticed that the direction of current flow is from positive terminal to negative terminal of the battery. So positive to negative. Wait a minute. Either is electricity electron flow, shouldn't it be flowing from negative terminal to the positive terminal of the battery? So it should be the other way, like this. So you see that it flows from negative to positive. So it's the opposite of this. The direction that you see in the circuit is known as the conventional flow of current of electricity, where it's a positive charges that moves from the positive terminal to the negative terminal. Why is there similarly two conflicting directions of electricity flow? Let's talk about history of conventional flow. When scientists first experimented with electricity, they can only see the effects of the flow of electricity. So when you close the switch, it lights up. They actually cannot see what is actually happening in the electrical conductors. So they hypothesize that something is flowing in the wire and they assume that the flow consists of positive charges and thus flow from positive to negative. And subsequent hypotheses and experiment developed all worked well and the results were as predicted by theories and were used for the next 150 years without any problems at all. However, scientists subsequently found out the electrical flow is actually negative charge and the flow is actually from negative to positive terminals of the battery. So the scientists' assumption was incorrect 150 years ago. However, all the previous theory were established based on the wrong assumptions still works perfectly. So they decided not to correct them. Instead, they label the incorrect positive charge flow as conventional current to distinguish it from the actual flow of the electron flow of electricity. So, all circuits are designed and drawn with an understanding that conventional current direction is used and not electron current flow. Why did scientists took so long to discover their error? Why is it that something that is completely wrong, i.e. positive charges moving or conventional direction current of the positive to negative terminal still works perfectly in designing and analyzing electrical circuit now. Let's use an analogy to explain. Look at the following sequence of diagrams. Comparing the first and the last diagram, what do you think has happened? Do you observe that the yellow block has moved from left to right? Let's look at another set of diagram. Notice that we have the same starting diagram and pay attention to what happened next. Do you agree that the end result is the same as the previous diagram? However, what has actually happened in this case? Did the yellow block actually move from left to right? It is actually the green blocks that have moved from right to left that creates the end diagram. So this is actually very similar to what scientists faced when they first experimented on electricity. They could only observe the effect of the flow of the electrical current but could not see what is actually happening. So they made the assumption that it was the positive charges or yellow blocks that move from left to right, but in the end it turned out that it is the negative charges or the green blocks that move from right to left. However, looking at the end results are the same, which made the error very difficult to catch. That's why we still use conventional current direction in our design and analysis of the electrical circuit. In summary, yes, electron flow is the correct direction of the electricity flow, but when we analyze, design, or draw circuit diagram, we always use or label your current direction using the conventional current and not the electron flow direction. So that's all for now. Please subscribe and support my channel. For my other physics video lesson arranged according to topics, please visit my blog at boringphysicsteacherswordpress.com. You can subscribe to my channel to be informed when I upload new physics video lessons. Thank you.